Hey y'all. Here is your angle similarity applications. So I'm going to go through this with you, pause when you need to slow down, and ask me any questions. I have my calculator ready, and here we go. While playing tennis, Matt is 12 meters from the net and 0.9 meter, which is 0.9 meters high, so this is the net. He needs to hit the ball so that it just clears the net and lands 6 meters beyond the base of the net. At what height should Matt hit the tennis ball? So we're looking at how high Matt should hit the tennis ball. Because I'm talking about angle similarity, I know I'm talking about triangles. So I'm going to show you how to, part A, sketch a picture. It's going to look something like this. So if this is Matt right here, and the net is somewhere around here. So we're just going to call this, the net. We know that Matt is 12 meters from the net. So this is 12 meters. And we know that the net is 0.9 meters high. So there's the net. And then he needs to hit the ball so it clears the net 6 meters beyond the base of the net. So here's the base of the net. So this needs to be 6 meters. And this is where the ball is going to land. He wants to hit it up here like a serve, and it's going to clear the net and then land. So how high does he need to hit the ball? This is our missing value right here. How high should he hit the tennis ball? Now, if you notice, I have one big triangle, and then I have one small triangle underneath. So I can see my small triangle right here. I'm just going to kind of shade this in for you. And then I'm going to redraw my big triangle so you can view them as two separate triangles. These are similar triangles because they both have a right angle right here, right angle. And then they share this angle right here, and that is what makes them a angle similarity because they have two angles that are congruent. The right angle is congruent to each other, and then they share this angle. Now the big angle, this is what value we're looking for, x. And then this whole side right here is 12 plus 6. So this whole side is 18 meters, 12 plus 6. So I got that by adding these two together. Now I have two similar triangles. I have this shaded triangle and this triangle, my two similar triangles, so I can find the missing value. I've labeled all my unknown information, and now I'm going to solve it using a proportion. X is the value I'm looking for. X comes from this big triangle, so I'm just going to put a little b here. And X corresponds to 0.9. Those are both the vertical amounts. X corresponds to 0.9, so I'm going to put 0.9 on the bottom. The other value from the big triangle is 18. It's the base right here, 18. And 18 corresponds to 6. And then you can use your calculator to solve this proportion. You're going to cross multiply and then divide. 18 times 0.9 and then divide by 6. And we get x equals 2.7 meters. So that means Matt needs to hit his tennis ball 2.7 meters high. All right, so question 2. Rosie, let me scoot it up a little bit. Rosie is building a wheelchair ramp that is 24 feet long and 2 feet high. So again, I'm sketching and labeling all of my unknown information. She needs to install a vertical support piece. So a vertical support piece is, vertical, and it goes in just to make sure to keep the ramp always level down at the bottom. Like sometimes if all the weight is up here, it might tip the ramp kind of like a seesaw. So it's a vertical support piece. 8 feet from the end of the ramp. So that means this little part right here, 8 feet from the end of the ramp. What is the height of the support piece? So we're looking for this vertical height. I've drawn a picture, and I have labeled all my information. So you see the two triangles. You should see this big triangle. They're both right. And then I'm going to shade this in right here. And then we have the smaller triangle, and they share this angle in common. So angle similarity. So we need to solve by setting up a proportion. I'm looking for x. And x this time is on the small triangle. And x corresponds to 2 feet. And then I need to use another value from the small triangle, so I'm going to use the 8, and 8 corresponds to 24. So I can cross multiply and divide, and my calculator gives me 0.666 repeating, but that doesn't really do me a lot of good, so I'm going to change it to a fraction. You press math, arrow frac, and x is equal to 2/3 feet. 2/3 of a foot tall this vertical support needs to be. The whole thing is 2 feet, so we know it's not going to be very tall, so it's 2/3 of a foot. Okay, a couple more. I'm going to show you number 3. Number 3, solve for x in the set of similar triangles. Hint, look at them as 2 separate triangles. So this one I'm just going to draw 2 separate triangles. So we see the top triangle, and then we see the big triangle. These are similar because they have these angles on the sides are congruent because you have parallel lines, and we talked about parallel lines cut by transversal, so these angles are congruent. And then this top angle right here they have in common is congruent. So this small triangle right here is 32 and 40. And the big triangle right here, what is that? 56. And then this is 40 plus x. So we have to add the whole side, 40 plus x. So in order to find x, we're going to set up a proportion just like we did before. And it doesn't necessarily matter where you start. If this is the side that we want to find, we can start there. 40 plus x. That corresponds to 40. See, they're on the same place in 2 separate triangles. This comes from the big triangle, so I'm going to use 56, and 56 corresponds to 32. Now, maybe you remember we worked on solving this from before. I'm going to cross multiply, and 40 times 32 is 1,280 plus 32x. Remember, I have to distribute 32 times 40 and 32 times x. And 40 times 56 is 2,240. Now I'm going to subtract, and 32x equals 960. I'm going to divide by 32, and x equals 30. Okay? And then number 4, it's very similar. Solve for x in the figure below. So you should see 2 triangles. I'm going to shade in my smaller triangle right here, and then I have my big triangle. Again, these are similar because they share angle M. Angle M is what they have in common. And then this angle right here, R and N, are congruent because I have parallel lines. All right, so we are going to solve it by setting up a proportion. We want to find x. I'm going to say this long side right here, MN, is 10 plus x. And this long side corresponds to 10. They correspond. Then I have this long side, MP, is 13. And that corresponds to 8. I'm going to cross multiply, and remember I'll show you this time that you have to distribute. 80 plus 8x equals 130. 8x equals 50. And then 50 divided by 8 is 6.25. And that's okay to have a decimal. All right. So that is the front of your application notes. Now try some of the problems on the back.